Hello, my name is Ryan. In this video, I want to talk about limits and continuity. Continuous function is a function that does not have any abrupt changes in the value. The graph below can be defined as continuous function because the whole graph has certain y value and it is connected during the whole interval. To define continuity, the graph must satisfy three conditions. First condition is that fa should be defined. This means that there must be certain y value at point A. Second is existence of the limit value. This means that there must be a approaching value of y as x approaches to A in both positive and negative direction. Third means existing limit value and actual value must be equal. If any one of the conditions are not met, the function is not continuous at x equals to A, and in that case we can say that the function is discontinuous at the point. Limit is the value that function approaches as input approaches to some y value. Often you can find the limit, you can plug the x value to the function. Sometimes if the graph has an asymptote, the limit has positive or negative infinite value. For example, let's say that we have gx is equal to x squared when x does not equal to 2. And let's say that when x equals to 2 is equal to 1. As you can see in the given function, the graph is not fully continuous, it has discontinuity. If you graph it, we can see the parabola and a hole at when x equals to 2. When we are about to evaluate g2, it's going to be equal to 1, and at any other x point, it will follow the value on the parabola. We must consider when we are trying to evaluate the limit approaches to x equals to 2, the graph approaches to 4, not 1. The right-hand limit and the left-hand limit approaches to same value, so the graph is said to have limit at x equals to 4. Any point which a function fails to be continuous is called discontinuity. Recognizing the three conditions of continuity helps us to understand concepts of discontinuity graph. There are three major types of discontinuity. First is removable discontinuity. This is also called point discontinuity. At this case, the limit exists because as x approaches to A in both directions, they approaches to same y value. However, because the actual fa value has different value with the limit value, the function is discontinuous. If the actual function value exists outside the graph or do not exist, the graph has removable discontinuity. Second is jump discontinuity. If you look at the second graph and trace it, we see that once we get to x equals to A, we see distortion of the graph. In this case, the limit value does not exist because left-hand limit and the right-hand limit are different. If the graph is making a jump of a point, you can easily define it as a jump discontinuity. Third is called asymptotic discontinuity or the infinite discontinuity. If the graph has an asymptote on x equals to A value, left-hand limit approaches to negative infinity and the right-hand limit approaches to the positive infinity. In the graph, both the left-hand limit and the right-hand limit are unbounded, so the limit does not exist. Additionally, there is no fa value, so the graph does not fulfill both conditions to be continuous. For the last part is defining removable discontinuity from rational function. Below is the example function. If you factor the denominator and the numerator, we get x minus 3x plus 2 over x plus 2, x minus 1. We can see there is common denominator, x plus 2. We can factor out the x plus 2, and in simplified equation we can see x equals to 1 is a vertical asymptote, and if you look at the highest degree of x squared over x squared, we can see there is a horizontal asymptote at y equals to 1. The key point is when we look at the original equation, we must consider x equals to negative 2 can't be in the denominator. Because if we plug x equals to negative 2, we get 0 over 0, which gives undefined value. Therefore, x equals to negative 2 can't exist on the function graph, Therefore, x equals to negative 2 exists as a whole in the graph. I hope this video covered the major points of the topic, and thank you for watching.